Have you submitted the physics? Yes, in your mail. I've sent up to 8 this week. Your mail today. Yeah, 4. Which one is it? They are starting exam. They are stopping me where you are finished. What of my charger? I did not put my charger yet today. Your phone charger? Yeah. Yeah, you're welcome. Huh? Hello and welcome. Today we're going to be looking at maths. Maths. Okay, I'm going to scroll down to mathematics. Okay. Incredible. We are continuing our learning. This is for WAEC. We are not stopping yet. Can't stop. Yeah. Let's look at number-based system. Base numbers. That's the first topic in mathematics. Let's look at it together. Okay, you can play this video. A base number or a number base is a system of counting in which certain units make up a bundle. The bundle does form the next place value. Base number system, that's what we're looking at. We have different ways you can count it. It's not necessarily 1, 2, 3 to 10, which is popularly known as base 10. That's the normal way we count. Whenever you are counting, and you're saying 1, 2, 3 down to 10, it is known as decimal count, decimal, base 10 counting. This is it here. It has this combination of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So whenever you have counting in this number, it is known as base 10. Another way, you can also call it decimal. So that is the normal way of counting. Base 10, decimal. That's the way you count every day. And it has the following numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the numbers that are in base 10. Now, there are other ways you can count. You can use what we call binary. Binary is the way computer understands numbers. And that is the system which the computer work. Call it the binary, or we call it base 2. And it has the following numbers 0 and 1, just zeros and ones. That is how the computer counts, zeros and ones. So you can have your counting in base 2, which is binary. You can have it in base 10, which is decimal. You can also have it in other bases like base 9, base 8, and the rest of them. Hello, welcome. Today we're going to be looking at number system. Number system is how. Okay. So that is it for that. So let's look at the various numbers that we can have. If you're talking about base 9, then it's from 0 to 8. If you're talking about base 8, then it's from 0 to 7. If you're talking about base 7, it's from 0 to 6. So do you recognize this pattern that when we're talking about base 10, it stops in 9, doesn't get to 10. When we're talking about base 9, it stops in 8, it doesn't get to 9. If you're talking about base 8, it stops at 7, it doesn't get to 8, but all of them start from 0 down or up to the number that is less than the base number being considered. So you have to take note of that. If they ask you what are the numbers that are contained in base 6, you should know that it's 0, 1, 2, 3, 4, and 5. 6 is not there, but it starts from 0. Oluwaseyi, can you tell me the numbers that are contained under base 4? Base 4. What are the numbers in base 4? Can you tell me?
0, 1, 2, 3.
0, 1, 2, 3. Perfect. Tell me the numbers that are in base 7.
0, 1, 2, 3, 4, 5, and 6.
Perfect. So the number that you're talking about, the base, let's say base 6. 6 is not supposed to be in the combination of numbers that you can have when you're counting on the base 6. But it starts from 0, but it ends at 5. So take note. So that is the 8. So let's say now the number 265. Luase, can you tell me the base numbers where you can have this number 265? 265. What are the possible bases that can have such number combination?
Base
Apart from base 10. Base 10, definitely. You have a number like 265 in base 10. We all know that. Then what other number can have that? 265.
Base 9.
Base 9 can have it quite all right. Base 8 can have it.
Base 7.
Base 7 can have it.
That's all.
That's all. Because base 6 cannot have it because of the availability of 6. So whenever you can have numbers ranging from 0 to 9, 190, all those, they are because you are counting in base 10. If you are counting in base 2, you can't see such numbers. If you're counting in base 2, you can only see 0, 1, 0, 0, 1, 1, 0. You can never see 2. Oluwaseyi, are you clear on that?
Yes, sir.
Okay, so I want you guys to understand the basics of counting. Very important. So when you're talking about base 10, you're talking about numbers ranging from 0 to 9, excluding 10. When you're talking about base 9, you're talking about numbers ranging from 0 to 8, excluding 9. When you're talking about base 8, you're talking about numbers ranging from 0 to 7, excluding 8, that base that you're talking about. So when you're talking about base 8, you're talking about numbers that doesn't have 8 in the bowl. So you need to know this combination. Okay, so let's look at the binary system, which is just 0 and 1. When we're talking about binary system, we're talking about only zeros and 1. So if you're talking about 0 is similar to 0 in base 10, 1 is similar to 1 in base 10, that binary of 1. So the number 2 in base 10, if you convert it to base 2, it becomes 1, 0. And the number 3 is 1, 1. And the number 4 is 1, 0, 0. So take note of these arrangements. Then you can also have other bases like hexadecimal, base 6, base 8, and the rest of them. But most importantly, in your exams concerning base number, you're going to be asked and you're going to be tested on your ability to convert from one base to the other. Mostly from base 2 to 10, or 10 from other bases to 10 and backwards. So we're going to be looking at all these conversions and we're going to try to understand them. So let's play this before we go to conversion. Hello, welcome. Today we're going to be looking at number system. Number system is how we do our counting, how we do our counting. Normally in the world, we count in base 10. We count in base 1, base 10, or call it decimal or ordinary. Exactly. And this counting involves numbers from 0 to 9, 0 to 1. Find out that every number you're writing in this board is always from 0 to 9. You know why? Because we always counting from 10. You want to write 588 naira, 568. You know, this 4, can you find it in the 10 number? Yes. This 6, can you find it? Yes. This 8, can you find it? Yes. Because we are counting in base 1, 10. Exactly. If you are doing computing and other areas of life, you can be counting in base 2. You understand? Like the basic computer machine language, these numbers in base 2. And base 2 numbers are only 0 and what? 1. Only 0 and what? 1. Base 2 binary. Only 0 and what? 1. Exactly. So your essence of learning base number is to be able to either work in base 10, which is the normal way of working, or work in any of these other bases, base 9, 8, 7, 6, 4, or any base. Exactly. And like I told you, in computing, they normally use base 1, in programming base 1, 2, because they are seeing functions of mainly zeros and 1. So if you have such number as this 1, 0, 1, 1, 0, 0, 0, 1, this number is in base 1. Base 1, 2, because it's comprising of only 1, 0 and 1. Okay, let's continue. Let's move over to the conversion proper. So let's try to convert from example. 101 01 base 2 into base 10 number. Convert 110101 base 2 to a base 10 number. So how do we do this? First of all, we write 110101 and base 2. What is command? Power expansion. Power expansion. How do we do it? We take the first number, which is 1, multiply by the base, which is 2. All to the power of the remaining number, 1, 2, 3, 4, 5, all to the power 5. Plus, we take the second number, which is 1, times the base, which is 2. All to the power of the remaining number, 4, 1, 2, 3, 4. We take the third number, which is 0, times base 2, all to the power 3. Plus the next number, 1, times 2, all to the power 2. Plus the next number, 0, times 2, all to the power 1. And finally, plus the last number, 1, times 2, all to the power 0. So the first number, 1, times 3, all to the power 1, 2, 3, 4, 5. The second number, 1, times 3, 2, all to the power 1, 2, 3, 4. Plus the third number, 0, times 3, 2, to the power 1, 2, 3. Plus the fourth number, 1, times 2, to the power 1, 2. Plus the fifth number, 0, times the base 2, to the power 1. Plus the sixth number, 1, times 2, to the power 0. So we now simplify. 1 times 2 to the power 5 is what? 2 to the power 5 is 92. Plus 1 times 2 to the power 4 is what? 16. Plus 0 times 2 to the power 3 is what? 8. Plus 1
Yes.
times 2 to the power 4.
David, you have a question.
2 to the power 1, 2.
Please ask your question, David. David, your voice is not clear. I can't even hear you. Wow. Okay, let's keep going before we can sort them out. So we have here conversion from other bases to base 10. So in converting from other bases to base 10, we use what we call successive multiplication. So now, let's say you want to convert 110101. You want to convert it to base 10. What you do is that the first number here, say 1, you multiply it by the base of that number you're converting from to base 10. And you raise it to power of what is remaining. So this is what is remaining, 1, 2, 3, 4, 5. So it's going to be raised to power 5. Then you put plus. Then you go to the next number. So the next number is 1 again. So since 1 is the next number, we multiply by the base again. And we already know that the base is 2. Then 2, the exponent we are going to take is the numbers that are in front. And we have, after this first one, this second one will have 1, 2, 3, 4, 4 numbers. But very importantly, if you take these 4 numbers, you already find out that the exponent will always be decreasing. So that means once you have the first one being raised to 5, it's likely that the second is going to be raised to 4. The third is going to be raised to 3. 2, 1, and 0. So that without even counting, once you're able to establish the number for the first one, the second one becomes easier for you. And take note that the number that you're always raising is the base of your exponent is always 2, because 2 is the base number that you're considering. Now, let's say you're converting a number that is to base 8. In place of these 2, what you would have been having is 8, 8. And you will still have the exponent counted as if you're rounding down. So in any way you're having it, that is the way you're supposed to do it. Whenever you're converting from order basis to base 10, you always use what we call successive multiplication. Unlike when you're converting from base 10 to other numbers, you use what we call successive division, where after dividing, you pick up the remainders. You count them from down up, the remainders from down up. Then it becomes what you need. So I don't know whether this is clear. Oluwase, is it clear?
Sir?
Is it clear? The way to convert to 10, is it clear?
Yes. Yes, sir.
Hey, Michael, did you understand it?
Yes, sir.
Okay. So David was trying to ask a question. Let me check the chat and see. Okay, what about power expansion? Is it extension or you wanted to run expansion?
Sorry, it's expansion, sir.
Expansion, good. That's what we are doing already. Then successive division is when you want to convert from other bases. If you want to convert to base 10 from other bases, you use this power expansion. But when you want to reverse the conversion, then you use power expansion.
Okay, sir.
So we are converting to base 10. That's why we are using power expansion. So if you're converting from base 10 to other bases, then use successive division. So it's very, very important that you know this. Then, if you're also giving addition, if you're going to add, if you're giving addition, then you're supposed to use what we call, make sure that you always convert the numbers that you're supposed to add. Convert them to base 10 first, then add them and reconvert back to the base that you're giving it. So that's the secret to doing it. Even if you're giving any mathematics to do, like division or any form of thing to do, make sure that you always convert to base 10. Then solve the problem. After solving the problem, then convert back from base 10 back to the base that you want. Yeah, somebody wants to say something. But no, you have to go and think first. Yes. Somebody wanted to ask question. Okay, so let's continue this. 1 times 2 to the power 0, 1. Anything to the power 0, 1. So 1 times 2 is 0 plus 1 times 16 is 16 plus 0 times 8 is 0 plus 1 times 4 4 plus 1 times 1 1. That's what we have. So add it together, 32 plus 16 plus 4 plus 1 will get 53. So that's what we have. So whenever you want to convert from 10 to another thing, you just take the numbers one after the other, but the base of 1, 3.
Yeah.
1, 3, 4, 5 to base 10. 1, 3, 4. Can somebody try this one? 1, 3, 4. base 5 to base 10. Can somebody quickly try it? 1, 3, 4. Base 5 to base 10.
Sorry. Is
Can
that
someone try that?
Who are you seeing yesterday? Wait, no, not before.
Okay, can somebody quickly try 1, 3, 4, base 10, base 5 to base 10?
Yes, sir.
Okay, what did you get?
44 base 10.
44 base 10. Okay, did another person get anything different?
No, sir.
Okay, so Oluwase, you got similar thing, Abi?
Yes, sir.
Okay, so let's run it down.
Very simple. 1, 3, 4 is 5. The same as read the first number 1 times the base 5 to power 1, 2. Plus the second number 3 times the base 5 to power 1. Plus the last number 4 times the base 5 to power 0. So the power here is 1, 0, 0. So here you pick the first number, which is 1. And this one pick the second number, which is 3. This one pick the third number, which is 4. Now, one side to simplify, 5 to 4 is 25 plus 3 times. 5 to 4 1 is 5 plus 4 times. 5 to 4 0 is 1. Anything to 4 0 is 1. Now, break it down. 1 times 25 is 25. Plus 3 times 5 is 60. Plus 4 times 1 is 4. Now, 25 plus 5 plus 4. 25 plus 15 plus 4. Plus 4. 45 is 10. So 135 is 5. Simple as 44 is 10.
Okay. So that is very interesting. And I hope we all know how to do that. Okay. So we are back. Let's continue.
Okay, good one.
So let's look at these problems. Can somebody do this one? Convert to a number in base 10. And we have 5, 5. Who can quickly try this one? Convert to a number in base 10. Five, 553 to base 7 to base 10. You can do that. Yeah.
So I got to 83.
I got 23.
Anybody able to do that? Huh?
Yes, sir. So I got to 83.
23, okay. So let me scroll down and see. Somebody say you got 23. Is it 283 or 23? What say?
283.
283, okay. So we can see it now. 5 times 7. 7 is the base to power 2 because there are 2 in front. 5 times 1 to power 1. 3 times 7 to power 0. David, anytime you're logged on, like the echo from your distance is always disturbing the class. I don't know why. You have to always mute, please. Okay. So let's look at more. Can somebody try out this one? Find the value of this plus this. Let's see whether you can add in base 2. Now, whenever you're adding in any base, you should make sure that the number that you get after adding doesn't exceed the numbers that are possible in that very base. So I want somebody to try out this one.
Sir, I got 100 1011.
Okay. 100 Perfect. That's all we have here. So you guys should take note. All these are from your WAEC past questions. So they are likely questions that you're gonna be seeing in your exams. Likely questions. So like, well, I'm impressed by the number of people that joined today's class. Good one. You're always going to know that early preparation is good for you, like I've been hammering since. You join the classes in time. Now that we are starting, you have enough time for you to practice, have enough time to improve, have enough time to do a whole lot of things. So it's very important that you join up in time. And it is not just to join up. Once you join up, make sure you're following up with the assignments. Once we are doing assignments, make sure you're doing assignments with us. Make sure you submit your assignments in the various groups. It will help you to keep working. So you can see in this addition, we have 1 plus 0, 1. Why? Because 1 is still within base 2. Here we have 1 plus another 0, 1. But here that we have 1 plus 1, you cannot have 2. It's not possible that you have 2. So you can only have 0, remainder 1, which is what you have here. So that is what you also do here. 1 plus another 1 can only have 0, remainder 1. So you carry that one, you put here. So this one becomes 2 again. So you have 0, remainder 1, then you put the 1 over here. So it's always good that you note that in numbers, once it's number 2, you can never have 2. It has to be zeros and ones. So once it's 3, you cannot have 3. It can be 2, 1, and 0. Okay, this is perfect because from this we will learn about the successive division. Convert 27 base 10 to another number in base 3. Here we'll try to convert 27 base 10 to another number in base 3. So in converting to another number in base 3, you have to divide successively by 3. Then after dividing, you now collect from down upward. So whatever you have becomes your converted number. So here you have 23 divides 27. We know it's 9. 9 remainder 0. For 3 divided 27, it's 9. 9 remainder 0. So you write 9 remainder 0. Always write the remainder because the remainder is what is important. That is what you're going to collect. David, put your mic on mute so that I can talk and not hear my reverb. Okay. So when you say 37 divided by 3 is 9, remainder 0. 9 divided by 3 is 3, remainder 0. 3 divided by 3 is 1, remainder 0. Now, 3 divided by 1 cannot go, so that's why I'll call it 0. Remember that very one. So you now collect your number from down. You have 1, 0, 0, 0. 1, 0, 0, 0, base 3. Oluwaseyi, is this one clear?
Yes, sir.
Chika, you are joining late. Okay. So we're gonna.
I have problem.
Okay. So let's everybody try this one. You see now, you see the way our lesson is going. Plenty solving of problems. Plenty solving of problems. So after solving all these problems, there is no how you are going to see something that is totally different from what we are saying now. It must come out from there. So let's try this one. Convert 72 base. Base 6. Our answer is in base 3. So they are not even tenants. So this 6 now, you have to make sure that you convert it first to base 10. Then any number you have in base 10, convert it then to base 3 and tell us the answer. So somebody should solve that.
Sir, please, the question again.
See, the question is convert 72 base 6 to a number in base 3. So let me see a very intelligent student that can help me out with this.
I got 1122.
You got what?
1122.
1102. Okay. That is not even in our option.
1122.
1127.
1122.
1122.
Okay, 1122. Okay. So other people should solve this.
So I got 1122.
1122 again, okay? So another person.
So I got 1122.
1122. Wow, everybody is having 1122. Incredible. So that means it's making sense. So we have 1122 as the right answer because converted these first and got 44. Then converting from 44 base 10 to base 2 using successive division. Here we use power expansion, and here we use successive division. Got this, okay. So this is it's incredible. And please, can somebody try this one? If 2Q35 is equal to this, what should be the value of Q? WAEC is not going to ask us something as difficult as this, but sometimes jamb can come out in jamb, but use it and drill yourself. Let's see. Let's try it out. So always note, whenever you see something like that, convert it to base 10. Then convert this one also to base 10. Then solve out. Then you get the value. That's the easiest approach, converting to base 10. So
Sir, the answer is 2, sir.
2, okay?
Yes, sir.
So let's wait for another person or some people. Yeah, sorry, please, I was having class.
So my answer is 2.
And I'm still having now. What's up? You want to come? I don't know. Yeah, you're still there. You're still there, ba? Huh? I'll call you once I'm done, please. Sorry. Yeah, thank you. So 2 people are getting 2.
So the answer is 2.
Okay, Oluwase, you're also getting 2. Chika getting 2. David, everybody's getting 2. So possibly it
2,
should be
sir.
2. Okay, you can see Q is equal to 2. That's nice. I like your abilities in that. So like from what we've done so far, you've known how to convert from base 10 to other bases and from other bases to base 10. Base 10 is normally our base because we naturally in the world, the common base will count in 10. So that's why it is the natural base to work in. But like I said, if you're going to be working in computing, in programming, you're going to be using base 2. So in other fields in life, you can also use other bases. So your ability to convert from one base to the other becomes very, very important. So are we ready for assignments?
We are ready, sir.
Okay, so let's give us some assignments that we should work on so that we have something to do. So my assignment this time around is always very detailed. And why I'm giving you a detailed assignment is because I want you to understand the concept very, very well.
Assignment.
I want you to understand the concepts very, very well before you start solving, since we have time. But once we stop about the concept, then we'll start talking about quick answering. So I want you to draw a table of the various bases that we have. You remember the table I opened up from base 2 to base 10. This is the table I'm talking about. This very table. So draw it, telling me the bases and the numbers that are possible in a given base. So draw this table, telling me the bases and the numbers that are possible for a given base. That's number 1. Then number 2 is I want you to show how to convert from base 10 to other base, and also from other base to base 10. I'm gonna give us an example of what I mean.
So I'll give you an assignment. I just do what I'm waiting for now.
Mildred, as you're talking, we're hearing what you're doing. We can hear you from here.
I'm sorry, sir.
You can mute yourself so that you can enjoy yourself and talk.
Okay.
Okay. Okay, so this is the assignment for the first one. I've talked about the table. I hope you guys got that. Then find X in this very arrangement. So show me full working. Find X in this. X base 10 is equal to 23 base 5. What is X? So like I told you before, convert everything to base 10 and solve out. So that is assignment number 1. Then assignment number 2. Assignment number 2. Please, I hope you're writing down so that you don't miss out. So whenever you guys, when you watch my, what's it called? My status, my WhatsApp status, I'm always gonna be using the best assignment for the day as my status. So whenever you see your assignment as my WhatsApp status, then you know that the assignment you submitted is the best from all that I've checked. You know that most of you, some of you are in different groups. So once you submit the assignment that I've given for the week, for the day, to the group where you belong, I'll go and check them through. David, please put your mic on mute. David, please. It's only your mic that echoes my voice. I don't know. Other people, even if they are not on mute, I'm not getting the echo. But once your own is not on mute, I'm always getting the echo. Okay. So once you see your assignment on my status, then you know that your assignment is the best. That doesn't mean that other people's assignments are not good. It simply means that I've gone through all the assignments and I've found out that yours is well written, well organized, well presented. So sometimes when I look at your assignment, I don't just look at you just getting the answer, but the way you present it in a very elaborate, explicit way. And once I find that, then I'll use that as my, what's it called? My status, my WhatsApp status. So anytime you check and you see your stuff as my WhatsApp status, know simply that it's because yours was done well and well presented. Okay. So the assignment number 1 is to draw out the first table that I said, telling me all the possible bases from 2 to 10 and the numbers that can be found in those bases. That's the first assignment. Second one is to solve this problem. Then third one is to give an example of how you can convert from one base to another. So the number you're converting is, if you're writing 432 base 5, 432 base 5 to base 10. Convert 432 base 5 to base 10. Convert 432 base 5 to base 10. And the second assignment is convert 234 base 10 to a number in base 6. 234 in base 10, convert it to a number in base 6. 234 in base 10. Convert it to a number in base 6. Okay, so those are the assignments. So I'll be waiting for you to send them in. Thank you. See you when I see you. God bless you.
It's got a-